All right, so we finished off last time with the cube root function, right? Talking about that. So let's go into the next couple of functions to think about would be, well, the next one is the absolute value function. So we have f of x equals the absolute value of x. Well, so we want to graph it and then be able to tell things about the graph, right? Domain, range, increasing, decreasing, min, max, so on. Okay? All the same list as last time. So, how do we start this off?
Plug in numbers.
Plug in numbers. So you can think about the domain to see what numbers you should choose, right? So are there any restrictions on absolute value of x? No, right? We can plug anything in if we want. So what should we choose? Sorry, just take this chair right there. I can't. There. Sorry. Okay, one more time.
-1, 0, 1, 2.
-1, 0, 1, 2, sure. So if we plug in a negative number, what happens?
Turns positive.
Turns positive. So -1 turns into
1.
1. 0 is?
0.
1 is?
1.
2 is?
2.
Okay. So this is a pretty basic graph, right? We have -1, 1, 0, 0. Excuse me. Thank you. 1, 1, and 2, 2, right? So that means our graph looks like. I'm allergic to dry erase markers, evidently. 2. It looks like a V, right? So, what is our domain? I'm just kidding. It was a joke. I can't teach anymore. So, what can we plug into this function?
-infinity to infinity.
-infinity to infinity. Okay. What about the range?
0 to infinity.
Okay, 0 to infinity. With what type of closure on 0?
A bracket.
Bracket, because we can actually get 0. Right? That was a horrible bracket. I'm going to overemphasize it because it was horrible the first time. Okay, so, and everybody sees why it's a bracket on 0, right? Because we can actually plug in and get 0 as a value. All right, what about increasing? Do we have increasing sections? Yeah, we have parts that are going up. Where do they start?
0.
At 0. 2. With what type of closures? Parenthesis, because increasing, decreasing, constant are always parentheses, right? We never include our endpoints. So what about decreasing then? -infinity to 0 with parentheses. Constant?
No.
Nope. What about relative minimum? Do we have a minimum?
0.
At 0, yeah. So when x is 0, what about the value?
0.
When y equals 0. What about a relative maximum?
No.
My nose is just not happy today. We do not have a maximum because we never reach the endpoints, right? They go on forever, so we never stop. Okay, absolutes, right? Those are the relative. What about an absolute minimum? Do we have one? Yeah, it's the same thing. It's the relative min. And so is the value. Okay. What about absolute max? That's also the same as the relative max, right? There aren't any. Okay. Questions about this one? What if we restricted the domain? So what if at the very beginning I had said f of x equals absolute value of x when -1 is less than or equal to x, which is less than 2? What if that was the only part of the graph that we look at? So ironically, that's what we did. So we already know the points. We have -1 to 2 with an open circle, right?
Yeah.
Okay. So what changes now? What's our domain now? -1 to 2 with what type of closures? What type does -1 get? Because it's a closed circle. The point is there. 2 gets a parenthesis. Or because it was or equal to, right? And then not or equal to. What about the range? That one's a little weird, right? So remember the trick, you can always look at it sideways. So it's 0, because that's the bottommost, right? We're here. So where? To 2. So we have that part, essentially, of our range. So we have 0 to 2 with what type of closures? 0 gets a bracket because we're actually there. 2 gets a parenthesis because when we're there, we're not there kind of thing, right? It's an open circle that's there. Does that make sense? Okay. So do we see how our domain and range changed when we restricted what portion of the function we're looking at? Okay. So then also, obviously then increasing, decreasing, all those things change. So increasing is where? 0 to 2, because we stopped, right? With parentheses. What about decreasing? -1 to 0 with parentheses. Still no constant areas, right? What about the relative min and max? So the relative min is still the same, right? We didn't get rid of the bottom. So it's still there when x is 0. The value is still y equals 0 because we didn't change the equation any. Then what about relative max? Did that change? Remember, because relative cannot be endpoints. Okay? Because the definition of a relative extrema, we call them, we don't want to say min or max kind of thing, is that it changes from increasing to decreasing or decreasing to increasing. An endpoint doesn't change, it stops, right? So because it's not changing from one type of these two behaviors to the other, it doesn't qualify, even though it is kind of like they're at the top of their areas, right? So we still don't have a relative max. Our absolute, right, is still our relative for min. Everybody knows that I'm just doing capital A for absolute and then capital R for relative, right? Okay, just making sure, because my professors would always do crazy abbreviations on the board. I'm like, what does that mean? And you have to puzzle it out. So if I do that to you, please just tell me. Now, the kind of funky thing is when we do this restriction, we didn't change the relative max, but we did change the absolute max. So What is it? It's not quite 2, because we don't get there, right? It's like if we almost got to 2 kind of thing. If we switched it, right? If this was filled in and this wasn't, then 2 would be our absolute maximum, right? So it's like kind of right before 2. We probably wouldn't ask you for the absolute max on this one because you can't really write it, kind of thing, because it's not a single point value. Okay? Does that kind of make sense? If this was a filled in circle, then we could do it. All right, because it's an actual point then. But right now, it's like right there, kind of, but it's not part of the domain. Okay? Does that kind of make sense how I'm saying this? Because it's an open circle at the topmost point, we can't write down right before it. It's not 1.9. It's like 1.999 forever repeating. Okay? So we could say that it's at x equals 1.9 repeating. We could say that. That's fine. That's quantifiable. It's just not nice looking still. Okay? The computer won't ask you when they answer something like this. But if we can do this one, we can do the easier ones. Okay? Make sense? Any questions on when we restrict it like that? Yeah.
You say x is approaching 2?
Yes. Yeah. So that's why I said 1.9 with the 9 repeating.
Okay.
Because it gets really, really close to 2, but it doesn't actually ever get there. That's the only way we can write that down. Okay. So the next one is if we have g of x equals 1 over x. So this is called the reciprocal function, because it's just literally the reciprocal. So, well, where do we start? Ideas? I'm sorry? A table, yeah. And what values do we choose? -2, -1, 0, 1, and 2. Okay, we'll be consistent. What about -2? What do we get? -1/2. -1 gives us -1. 0 gives us undefined, right? Because we can't divide by 0. That's important. That's an asymptote. Okay. Then what about 1? 1. 2 gives us positive 1/2. So how do we draw this, right? Okay. So we have out 2 and out 1/2. Okay, so we can't plug in 0 because that gives us undefined, right? So at x equals 0, the y-axis, we can't do that. So that's an asymptote. Now let's think about one other little thing. Is there any way for us to get 0, right? Can we set this equal to 0? Is there an x value that will do that? Well, we just said if we plug 0 in, we get undefined. So no. Because there's not a variable in the top, this fraction can't equal 0. Okay? So that means that the y-axis is also an asymptote. Okay? So then we have -2, -1/2. So about there. -1, -1. 0 we can't do. 1, 1. 2, 1/2. So our function looks like this. Thank you. So when we have the asymptotes like that, we have our points, and we know that an asymptote means that thank you. And that it's approaching that line, right? It's what an asymptote means and does on a graph, is that it kind of restricts the area that the graph can go into, right? So you approach it and get really, really close to it the further you go. So, what is our domain? What can we plug in? Negative infinity to 0, parenthesis, union, yeah, 0 to infinity. Everything but 0, right? The only thing that is bad in that, what type of function? Reciprocal, yes, but it's we just had it on the test. I think I heard it. Rational, yes, that is a rational function. So, what's the domain restriction? Not 0, basically, right? So that's not 0. So what's the range? Is it different? No. We can get everything out other than 0 again. So it's the same thing, right? Being lazy. You can do that in the computer. It's called Control Copy, Control V. What about increasing? Are there increasing sections? Nope. It's all going down because it goes down here. It stops, so forget it, right? What it just did, and then restart, and it's going down. So that means it's all decreasing with the same as the domain, right? So again, the same thing as above, right? It's not constant anywhere. Does it have any extrema? Min or max? I had mentioned it a few minutes ago, so. That's okay. So, does this function have a max? Does it have a minimum? No, because all the ends are going forever, right? There's no peaks, there's no valleys, right? So there's no extrema. Are there any absolutes?
No.
Nope. No mins, no maxes of relative or absolute. Okay? So that's pretty much what we've been asking on all of these different functions, right? All right, now what if we want to work backwards? What if I give you the graph and we want to try to write the function from it? So this is where knowing so far what we've done would be called pretty much the parent graphs, right? We've done x squared, x cubed, square root, cube root, absolute value, reciprocal, okay? So all of those are the parent graph. Some other basics would just be like y equals x, just a line, things like that. So if I give you this graph, well, what does it look like first? It looks like x squared, yeah. What would the restriction of the domain be? So the domain is -2, to 1 with what closures? Open, so parenthesis, yeah, and bracket. So we said that this looks like x squared. Right? That's kind of our little thought to ourselves. So we would write that as f of x equals x squared for -2 less than x, because it's a parenthesis, right? So we're going from interval notation into inequality notation. Then, because it's a bracket, less than or equal to 1. Okay? Does that make sense, how we wrote that? Okay, we said it looked like an x squared. So then, what's the restriction? From -2 to 1, open and closed. Okay? And then we can go on further and do the range and everything else. Okay? But that's the part that's new. Okay, it's going backwards, essentially. All right, let's do one more of those, and then we'll go into the actual homework type problems in the section. All right, so if I give you the graph, so this is what we would call a piecewise function. Okay, so it's going to be in different pieces. So let's look at the one part first. What does this look like? What of the different graphs that we've done so far does it look like? That shape. A cube root, yeah. So we think this part looks like a cube root, right? What does this part look like? It looks like a horizontal, yes, which is a y equals. So we think it's just y equals 4. Yeah. Okay, so now what we would do, we would say that f of x is equal to these pieces. So we think it's the cube root of x and 4, but where, right? So we can say 4, or we can say if. Usually for piecewise, you'll see if. Where do we think the cube root is? What would its section be? Negative infinity to 8 with what types? Parentheses. So when we do inequalities, we don't usually put negative infinity or any types of infinity, right? So we'll just put this part. When x is what with 8? Less than, just less than. Okay? Does that make sense so far? What about the y equals 4? What kind of area does that look like?
Everything greater than 8.
So 8 to infinity with what closure? Bracket, because it's a closed circle. So what do we do on this part? 8 is, or x is what to 8? Greater than or equal to. Yes. Does that make sense for this one? Because this shows up a whole bunch on the homework. So you have to look at graphs and write them. Okay? We'll do another or two practice of this. Yeah.
On the claims, only 3.2 and 3.3.
3, 2, and 3, 3. Yeah. Mm-hmm. Okay. So, what's the domain? The overall domain of the function? Negative infinity to So look at the whole graph.
Negative infinity to infinity.
Yeah. Just because it breaks here doesn't mean the domain breaks, right? Because these circles are overlapping, right? But not only one of them is filled. Okay, that's important. Otherwise, it's not a function, right? And then that one of them is filled means that there's no break. If they were both open, then we'd have a break at 8, right? Because 8's not included anywhere. But because one of them is filled, we can plug any number in and get somewhere on there, right? One of the lines. What about the range? So, what sections do we get? Do we go all the way down to negative infinity? Yeah. So then where do we stop? Anywhere? At 2, right? And then just at 4. We don't do anywhere in between 2 and 4, right? Because this stops here, and then that's not really there. That was just me. And then we just have that line. So we would write this part, the negative infinity to 2, with a what? Parenthesis. Union. Now this part's weird. We've not seen this before where it's a straight line. So it's just a value. How we write it just a value is the squiggles and just the number. Okay? So squiggle, parentheses, brackets, whatever they are. Still don't know. And just 4. Okay? That one's a little weird on that part. Questions? We good on that one? Increasing? Negative infinity to 8. And then decreasing? No. Constant? 8 to infinity. All parentheses again. Minimum? Nope. Maximum? No. Because this is kind of like an end point, right? It's not decreasing afterwards. It's weird. And then constants are just nothing. Okay? Because they're not going up or down. All right. What's the absolute maximum, though? Where y is 4, so it's somewhere on there, right? It can happen anywhere on that constant line. So the absolute maximum value would be 4. That one's a little easier to answer, because that's the top of the function. Okay? All right, let's look at some of the stuff in the homework. So, in 3-2, were there any questions? Anything from 3-2? I'm going to just start there, get them out of the way. Then we'll come back to 3-3. Nothing? No, we're good, especially because this section is still due tonight.
Go through the questions. Should go start on number 10.
On 3-3?
Yeah, and then work from there.
Oh, shoot, I did it wrong. Hold on. Okay, so was there anything in the front parts? I mean, these we've pretty much done in class. This one we're good with. This is just, again, kind of more or less like what we've done in class a lot of, right? Oh, and you can't see any of it because they're still writing there. Okay. These are the ones that were the trouble, right?
Yeah.
Yeah? Okay. Okay, so first part is just plugging in, right? So how do we figure out where we should plug in?
I don't know which side to look at.
We look at this, yeah. So we have -2. Where does -2 fit in these? The top one, yeah. Because -2 is right here, and its x is or equal to -2. So we only plug into this top function. We don't care what -2 is in here. We only care what it is here. So if we plug -2 in, what do we get? 3 times -2 is -6 minus 1, -7, right? Don't do it that fast. Actually, take your time. So we have -7. And then 0. Where's 0 fall in? And the top one as well, because 0 is in between -2 and 2, right? So another way to check is just plug in the number for x right here. See if it satisfies the inequality. Okay? So because 0 works right here, we can plug 0 in.
But 0 worked out too.
So 0 is greater than 2? No. That's okay. So we only plug in 0 in the top. So we get what? -1. Okay. And then where do we plug in 2? Only the bottom because it's or equal to in the bottom, right? The top is just less than. Okay? So what do we get in the bottom when we plug in 2? -1. So now we want to try to figure out the graph. So let's write down those points, right? We had f of, hold on, I forget that I have to write for the recording as well. We have f of -2 equals -7. F of 0 equals -1, and f of 2 equals -1. So those are our 3 points. We want to try to figure out the graph here that has all 3 of those points. Okay? So another thing to look at is that it has those correct type of closures, right? Open and closed circles. So what type of closures should this be? We should be closed, open, closed, closed, right? So the first piece should be a closed and an open, and then the second piece should be closed, closed.
Oh, so the second.
So the only one that even works is this one. Yeah, because this piece is closed and open and closed and closed. All the others are closed, 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 all open, or open and closed, open and closed. Okay, but let's still check, because it doesn't hurt. Let's make, because that's the one we think it is, let's make it bigger so we can actually see it. And everyone, knew that they could do that, right? You can even take it out into a pop-out and make it even bigger than it will let you in the window. I really like doing that because sometimes when it makes it small, it distorts the graph and makes you think that it's right when it's not. And I've literally seen the graph, when you make it pop out, change. Okay? And the pop out is the correct version. I don't know why it does that. So, does it have what we want? We have f of negative 2 equals negative 7. Well, negative 2. Oh, sorry, they're going by 2's. I didn't see that at first. So it's also good to know the interval on your graph. Otherwise, none of them will look right. So we have negative 2, and then negative 6 would be here. So right in the middle is negative 7. Then we have f of 0 equals negative 1. So 0 right in the middle to be negative 1. And then 2 is also negative 1, right? Because we can't plug into this one because it didn't fit there, right? So that's why it's an open circle. And then this one's closed. Does that make sense? How to pick that? Okay. So we pick B and keep going. So what is the domain? So let's pop it back out and let's go ahead and figure out the domain and the range because, well, we know it's coming. So what's the domain of this function? Negative 2, so the domain. Negative 2 to, well, they overlap, so we're good. So we keep going to 4. With what type of closures? Brackets on both, because they're both closed circles at the ends. Okay, what about the range? Negative 7, because that's the bottom. To what? The topmost piece. Because this one is completely overlapping, right? Y value wise, we don't even really have to care about him. He's there for the X kind of thing, right? But because this line gets all of that Y for us, we don't have to look at him really because it's completely overlapping. So the topmost value here is 5, right? With what type of closures? Bracket, parenthesis. Does that make sense? How we did that? So I know that was kind of a lot. Question on this one? Yeah. You wouldn't write it out because you want to, if you just write out integers, you're missing all the decimal points in between. You don't want to separate them because these points are overlapping and one of them is open and one of them is closed. So because they do that, we can write it as one piece. If they were separated and there was a gap, then we'd have to do 2 pieces. Or if this one was open, then we'd have to pull out 2, right? Just like how we pull out a value in rational functions for their domain. Okay? Anything else on this one? No. Okay, because I'm just going to skip typing in the domain range. Okay, what about this? This is a little bit of a mess, right? So, first we want to, again, plug in, and then we want to sketch the graph. So I definitely want to do that part for sure. So, we want to plug in 2. Which piece do we use? Where does it satisfy? The middle, right? So 2 is greater than or equal to negative 2, but less than 3. It's not less than negative 2, and it's not greater than 3. Right? So we plug it into the middle. We plug in 2. What do we get? 2, because it's the absolute value. Okay. Then negative 8. Where does negative 8 satisfy? The top. Yeah. So what do we get? Just 5, yeah. No matter what we would plug into that, we'd get 5, right? As long as it fits into x is less than -2. Okay. What about the bottom, f of 5? Where do we plug it in? The bottom, because f is greater than or equal to 3. So what do we get? -6. Oops, if I'm typing. Okay. Now, we want to graph it again. So, these pieces, see how the kind of domain range, that's a really bad word to use for that. The domain width. I don't know. They don't overlap, right? They just connect because the numbers on the ends are the same, right? So there won't be actually any overlap, not like this one. This one is just bad, right? That is not a function in any way. So you can get rid of those options. So this one would also not be an option, right? So far we already have a 50% chance now, right? So then let's look at our closures. X is less than -2. And at 5, so it's open. So at 5, it's not closed, right? So far we're pretty sure it's not that one. And we know it's not those two. So could it be this one?
Yeah.
Yes, because it's open. Let's just check the rest. So then we have the absolute value, so the v, right? From -2 to 3 with a what and then a what? Closed and then an open. So closed and then open. So far we're real good. What about the last? -6, 3 and on, closed. So we're good. So it's this one. Does that make sense? So make sure that all of your options are functions. Then make sure they match, kind of thing. Open and closed, and that they're where they should be. Okay, and then they want the domain and range. So I'm just going to pop that out, and we can get the domain and range. So let's do our domain first. So what's our domain? Negative infinity to infinity. Because our open and closed circles overlap, open and closed. Right? We have one of each over top of each other. So it's negative infinity to infinity. And what's our range? This one's weird, right? We have the squiggle at what? -6. And then we have u. And then bracket 0 to what? The open one, because it's higher of the overlapping v piece, right?
So that's
3, right? And then union, squiggle, at what was that? 5? Okay, so let's look at that one more time. If we look at the y value, where we have something, right? We have something here, here, with a closed and then an open, right? And then we have something here. That would probably be a little bit easier to go from to get this range, right? Because we said we have something here, we have something on this section with closed and open, because it's here but not here, and then we have this point. That's pretty easy to transfer to this, right? But looking at it the other way is maybe a little harder, or whichever way you like better, okay? Whichever way makes you see the range a little bit easier. Questions on this one? Any other problems that you wanted to see? Or a question on this one? A different problem? What? Question 12? Yeah, this one's also a really good one to do. All right. So I'm just gonna let those of you know right now that because people have left in the middle, I am going to be taking attendance at the end of class. So, because I actually find it kind of rude for people to get up in the middle, for those of you trying to pay attention. And those of you maybe looking at your phones and your computers a whole bunch. Yeah. So, okay, how do we write this?
It's only A and B.
No, it's the full gambit. So, first we should figure out kind of what we have going on here, right? We have two pieces. We have something that is, let me get rid of this over top of the graph again. We have this piece that's just less than, right? And then we have this piece that's just greater than. Well, this is less than or equal to, yes. So we want a less than or equal to and just a greater than. So we want those two pieces, right? So, does A fit?
No.
Does B fit?
No.
Does C fit?
Yes.
Yes. So, what's the function look like when it's less than or equal to? So basically what I'm saying, what's this look like? What type of function is it? It's a horizontal, which is a y equals. So at y equals what? -1. When x is less than or equal to, ironically, -1. Then, what's the other piece look like?
No, -1.
What's the function? It's again a horizontal, y equals -3. The y equals, right, the value right here is -3. Then where it is x is greater than -1. Does that make sense? So the first part of the piecewise is what is the function? It's the y equals. What does this line look like? Then it's saying where is it? Where do we look at domain-wise? This part was less than or equal to -1. This part was greater than -1. Okay?
So why do we have like 4 of them?
Because you have options. There's a lot of different options for how the piecewise could be set up. This was the only one that is the correct setup. Because all the other ones have
I thought you had to
different. No, you can't. Yeah, you can't.
That's what I was.
Okay. Anything else on this one? On this question? We're good on that one? Okay, so because it is the end of class, I'll continue to go over any if anyone has questions still. But for those of you that would like to leave or need to leave, because I know one of you does, I will do attendance now. So I'll just put it on the front table up here. So just sign out, I guess, technically, if you're leaving now.